Hello everybody. So for this video I'm going to go over the exam 1 review. Sorry for getting this out kind of later on, but there was a few issues on the exam I had to sort of go through, and I didn't want to make a video yet until I really was pretty sure I knew what was going to be on the exam. So now I have like a very good idea, so let's go ahead and cover the material on the exam. So the first thing is a few topics here that are kind of from the first chapter in the book that I didn't really spend too much time covering, but I guess now I can definitely talk about them. But these are not really too hard, so they're just mostly just kind of preliminary stuff which I skipped over because I didn't want to fall behind during the course, and I want to always be on par with the syllabus. So the one thing I didn't cover was the von Neumann architecture, which I guess I will cover this right now. Architecture. Nothing too insane about this. So basically, what the whole idea is, it's sort of the architecture of modern day computers. So basically, you have your CPU, which is your processor, it's that, and we have our main memory, which is like your RAM. I suppose correct. Memory. Okay. Memory. And then you have your various I/O devices. So you have different peripherals, mouse, keyboard, even your hard drive is also technically an I/O device. I mean, you could consider this as also a secondary memory, but really, from what I was told when I did a little bit of work in the past, hard drive is not memory, it's storage, so it's really an I/O device. But anyway, you have these three main components. Now, of course, computers are more new. You have your GPUs, graphics cards, and all that good stuff. But this is kind of like the classic sort of way of thinking about a computer. You have this one giant bus, basically, that sort of connects all of these together. So data is sent through a bus, and then it's going to reach destination for each one of these. This is basically the architectures. This is going to be just some kind of a bus, if you will. The bus is just sort of like sends data between different devices. So that's basically one thing you want to look at. There's not really more to just that, really, but I just didn't cover it in the first week just because I didn't want to really waste time on all that. So let's go on to the other parts of the preliminary parts for the exam. So basically, another thing about computers in general, as well as any type of program, it has to first be in memory before it can execute. So if you have a program saved on your hard drive, you have to first load it into memory, and then from memory, it's going to load it to your CPU. And of course, CPU can have its own memory, it has a cache memory and a CPU as well. But the idea is it has to be in memory first. In order for you to be able to run your program. So that's kind of like the whole idea when you do like a.out, it loads the program to memory, and it starts feeding the CPU instructions, and then it runs your program, essentially. So just to kind of make sure I covered all that. So let me see, what else do we have here? Remember the concept of syntax and semantics, which I believe I went over earlier, but it doesn't hurt to cover it now for obvious reasons. Remember, syntax is sort of like the how should I say, the grammar of the language, or the legal C++ code. So basically, it's just sort of the legal C++ statements. So basically, think of syntax. It's just like, in English class, you have a spell checker, basically. That's like a syntax. And the compiler is what really checks for this. So you may have noticed when you had your program, you compiled it, it told you what line there was an error on, so you went to that line in your code and you went ahead and tried to fix that problem. So that's syntax. That's like the rules of how you can write C++ code. So you can't write anything you want, right? I mean, there's a rule for what you can and can't write in C++. So basically, that is sort of the idea for how we handle semantics. So now, syntax. Now with semantics, basically it's sort of the logic of the program. So it's basically, so semantics is a case where it's sort of logic of the program and sort of how the program is sort of executing. Now, the thing is, for semantics, a debugger, or you as a human, you have to find those semantic errors. So for example, if you try to do a statement like you have like a variable, let's say you have a double variable like this, double x, and x equals, let's say 1/2, multiply it by 3, and you see out x, you may wonder, oh, I'm getting 0.0. Why am I getting a 0? It's supposed to be 1.5. Well, this is a case where the syntax is completely valid, but there's some semantic issues. There's some logical problems because, like, yeah, this is a problem. 1 divided by 2 is not going to give you 0.5. It's going to give you 0. Multiply it by 3 will give you 0. You typecast that 0 into x to make it 0.0. So basically, a semantics, to fix them, is usually a debugger, or you as the programmer, you have to look through your code and find why is certain parts not working correctly. That's more of a semantic issue. So now syntax is just basically the formation of statements. Make sure every statement has to be legal C++ code. So it's kind of like a spell checker. Semantics is kind of like the logic and the whole idea of the program. Kind of like writing an essay in English class. Spell checking is okay, but it's not going to make your document perfect, because you could have grammar issues. You could have used there, wrong, right? So that's sort of the idea. So pretty much just sort of know what these two types of issues are. Okay, it's another thing I didn't really talk about too much. Talked a little bit about them, but different data types, and the idea is that you have data types like integers, for example. So you have integers, and they're going to be 4 bytes of data. Okay, great. And like a character, so a char, or character, I guess, is going to contain 1 byte of data, which tells you, well, okay, how much can you store into an integer? Well, 4 bytes, remember, if you remember this, or if you've ever seen this, 1 byte equals 8 bits. So 1 byte in general is going to equal 8 bits. So 4 bytes contains 32 bits. So for integers, the amount of possible numbers you can store into integers, so you can have 2 up to 32 is the number of total numbers that can be stored. That's like the range of numbers. Now, you have unsigned and you have signed variables. So unsigned means it's going to store only positive numbers. Signed means you can store positive or negative. So this type of integers that are signed, which means integers that can store negative values as well, then a range is going to be essentially -2 up to the 32 up to 232, I believe. Now, it's going to be subtracting by 1 for me, so let me go ahead and actually make a modification here. Sorry about this, because you have to include 0 in this range as well. It's going to be basically -2 up to the 32 minus 1, that whatever value that is, or I would say maybe it's a +1, and then it goes to 0, and then it goes to 2 up to the 32nd power minus 1. That's going to be like the range of possible values. So that's how you can calculate that. So it's going to be a pretty big number, essentially. So integers can store pretty big numbers. Now, it's not that big. If you go into like giant numbers, this is not going to be big enough, but I mean, it's going to work for most of our assignments. So for character, it stores 1 byte, which means for character types, it's going to be 2 up to the power 8. It's going to be the total amount of characters you can store in one character variable. So this case over here, characters are not going to store negative values. So 2 up to the 8th power, I believe, is 128, which means that the range you can store is really 0 to 127. So these are possible ASCII values you can store into a character. So to 128, so if you start from 0, 1, 2, 3, add up, this is going to be 128 numbers in this range, and it's going to be 0 to 127. If you add all those numbers up, you will count 128 possible numbers. That sort of tells you how many possible ASCII values you have. So I definitely discussed that, I think, a little bit, but not in so much detail. Just kind of try to remember that, but that's basically the idea there. Anyway, I guess that's sort of at least the preliminary parts for right now. Let's go on to the other parts of the exam here. Okay, also try to remember precedence rules. Try to understand, let's see here. Try to understand precedence rules. So, sort of operator precedence. Oops. So try to remember the precedence rules. So I'm pretty sure one of the chapters in the book does cover this. Remember, multiplication happens before addition. The standard precedence rules. Nothing really too crazy there with that. But just try to sort of rank the different operator precedences. Basically, that's what you want to kind of do. That's going to be sort of what you want. So I didn't cover every single one of them, but for example, unary operators like plus plus, minus minus, unary operators like they have the highest precedence rules. That's the highest one, and then after that you have your other ones. So I'm not going to list all of them out, but I've already done that before, and I think the rest of them are pretty obvious, and I definitely did list them out before in class, so that should not really be anything too major over there. And then, there'll be a lot of questions in terms of being able to trace out different C++ code. So let me see. I think I'll probably cover that later on towards the end of this video, not quite just here. Let me see. Just know how input and output works. There's going to be a little bit of IO manipulator stuff, but not too much of that. So don't really have to worry too much of all of that. Just sort of know what fix does, set precision maybe. Just sort of know what those do. There's nothing really too crazy with that. So knowing how to do input and output is another important thing, but you've done that for your assignments up to this point, so nothing too crazy there going on. And of course, try to remember what typecasting is, or other words, trying to understand is actually trying to understand what static cast is, which I went over. I didn't use the static cast ever. I just kind of typecasted. Like for example, when I'd have like this, I would always in class just do int 5.2, but I think in the book they use static cast int 5.2, same idea, but sort of typecasting in general. That means you convert from one type to the other. So go through your quizzes for that. That's about really all there is over there. And let me see what else is. Let me see what else we have here. So I think that's basically the sort of the how should I say, the text, sort of like memorization part of the exam. There will be also some content memorized, and maybe to kind of remember some text stuff involving if statements, but I'm not going to cover that just yet. So I'm going to right now probably pull out one of my old exams. Actually, this one's not really too old. It's actually from last spring. And of course, I'm not going to use this exam on on our current exam, but it doesn't really hurt to go back and look at old exams so you can get an idea of what kind of stuff I might put on the exams. So I'm going to go ahead and just, I guess true or false part, you can kind of look through these as well. I could ask these true or false type questions again. Obviously, since, I know what I went over right now, I'm not going to ask the exact same true or false questions, so I'm sorry about that. But of course, they're going to be very similar. I'm going to modify them obviously for the current exam that we're on. I'm not going to keep them the same. But something like this, which we had on our quiz, to circle, try to figure out which one of these are legal identifiers. So that could also come up on an exam. Obviously, I'm not going to have the exact same questions. Remember, these are naming conventions in C++, and of course, remember what the conventions are. Not the convention, but the legal way of identifying a variable is the first character has to be a letter or an underscore, and then remaining characters can be letters, underscores, or digits. But the first character cannot be a digit. So for example, this right here starts with a 7, so this cannot be a variable name. This would have been okay, but apostrophe over here is not a underscore letter or digit. So we can see here that you can probably figure out which ones which one of these is sort of legal variable names or not. And of course, remember how constants work. Constants are always all capitalized. That is purely by convention, so there's no rule that a constant can't be a lowercase, and variables could be uppercase, right? But we have that convention just because when you're reading through your code, you want to be able to determine if this identifier, is it a variable or a constant. So if you see it all in caps, it gives you a big clue it's a constant, so it makes it easier to parse your code and look through it when you are debugging your program. And then these kind of questions could be on the exam as well. So I could do a couple of these. So it won't be the exact same question, but I pull my old exam out because I don't want to have to create on the fly. I'd rather use what I've done in the past because, of course, I could redo all these. So let's go ahead and do a couple of these examples here. And you can, of course, work the rest of them out on your own because you can always freeze the video and you can work on them. So let's go ahead and I'm going to go ahead and sort of work these ones out. So the following statement over here, of course, we do always in parentheses first. So we first do this. So 1 divided by 2 is going to give us a value of 0. And then we typecast that 0 to 0.0. Even though double wraps around this, it first has to compute this value before it can typecast. So this would be a 0, then double, you make it 0.0. So okay, cool. 0.0. And this is going to be, well, plus, this is going to be 1.5, because 3.0 divided by 2, remember, when one of these two operands is a decimal, the whole thing becomes a decimal. So this will be 1.5. So these both could have been decimals, but as long as one of these two are, decimal answer. So here, okay, fine, now we're going to do the other operations. So we have mod division and division. So of course, since they have the same precedence sort of order, we're going to do one that appears first from left to right. Okay, so 13 divided by 4, let me see, is 13 divided by 4 gives us a quotient of 3 and a remainder of 1. So this would be remainder of 1. And then plus 16 divided by 7, that's going to give us a quotient of 2. And then we're going to, of course, add this one up. And now we have a bunch of pluses, the same precedence rules. So we have 1 plus 2 will be 3. 3 plus 0.0 will be 3.0. Then plus 1.5 will give us 4.5. Now, some of these you want to be very careful that at the end, let's say, for example, one of the answers was actually 4.0 was the answer you would have calculated. Now, on the exam, if you put a 4 instead of 4.0, it will be marked wrong because even though you get the right numerical result, you messed up your type. So be very careful with your types. I would imagine for these questions, the only hard part is making sure your types are all in order is a really hard part, I would imagine. So I'm not going to do the rest of these. I'm not going to do these, but you can really work these out. These are really, you know, kind of grade school math. The only hard part is being aware of your sort of types. That's the only important part. Actually, I'll work this one out as well. Maybe I will work this one out because this might be sort of helpful. So this one's kind of a weird one right here, right? So let's do this one. So obviously, you know, well, anyway, let's go ahead and just, I'm not going to say anything else right now, but let's go ahead and work this one out. So we're going to first do what's inside the parentheses again. So we had this really weird 5.0 divided by 6 plus 1 divided by 6. So this result would actually give us the result of 1.0 if we do these calculations correctly here. Then we typecast it in to make it 1. So you have a 1 basically, multiply it by 2.9. And then this is going to be, well, in this case now, the highest precedence will be a division right here, and then multiplication at the end like that. So this is going to give us basically 0.75, multiply it by 3 plus 2.75 minus 1.5 plus that. And then you can go ahead and work this one out. So I don't want to really do this right now, but yeah, you get the idea. It's nothing really too crazy. I'm not going to have anything too insane, just, you know, just sort of know your order operations and know how to typecast and make sure your types are all in order. Nothing too crazy there. So okay, so let's go ahead and work these ones out. So this could be also a potential set of questions I can put on the exam for these operators. So we have to basically verify which one is true or false. So let's go ahead and do a couple of these right now. Let me see. I want to try to find one that I kind of swapped it around. I think I didn't, though. I sort of. Oh, here we go. A and E. So here we go. These two, I'm going to work these two out right now. So they're the same expression, but you notice I kind of swapped the ands and the ors around. So let's go ahead and work these ones out. So we're going to have 14 mod by 2, which will give us the result of 0, I believe. The 14 mod 2 is 0, it divides evenly, so this will be 0. Less than 12 divided by 2 is going to be 6. Minus it by 3 will be 3. Then we do this OR over here. Then we're going to do 4 squared, which will be 16.0. Then we typecast it to be 16 equals 16. And R and T, which I guess I'll just put this over here. So for characters, you know, these are going to be obviously not the same characters. It'll be false. But first, work this whole thing out. So right now, we have all of the sort of numbers calculated. So we first compute our numbers, and then we go ahead and do the comparisons. So this right here would definitely be true because 0 less than 3 is true. So I'll put a little T over here for true. That'll also be true. This will be false. So we have true, or true, and false. Now, we must be careful about the precedence order. So in this case over here, the AND comes before the OR. So we're going to do true and false first to get false, and then true or false gives us the result of true at the very end. So this part right here would evaluate the false because true and false is false. This whole part's going to be false, so true or false will give us true. Now let's go ahead and work the same thing out over here this time, however. Let's see what happens in this particular example. Let's think it actually works out to be the same, so this is actually a bad question on the this exam, but you know, I could easily tell you that, yeah, maybe you would think that if I swap these, it could be the opposite answer. Maybe it won't be, maybe it will be, so here's a little deception right there. So for this one, we can already kind of, you know, sort of look at these and say, well, these are the same, so I'm going to have just true over here and true or false. So here we would do a true and true part first to get true, and then true or false would be true again. So this will also come out to be true, but I could definitely be a little bit more deceptive and then maybe have it where if you don't do the ands and the ors correctly, so let's say for example, at some point, let's say for a hypothetical example over here, if I were to have had true and false or false, then, or I could have actually have done true or false and false. You can see here, if you're not careful, you can make a mistake. So and comes first, so true and false will be false, false or false. This will be false right here. This one though, we do the false and false part first to give us false, then true or false gives us true. So here's a case where if you think that's from left to right, the ands and the ors, you're going to get a wrong answer. The ands are always first. No matter where the and appears, the and gets evaluated first before the ors. So that's the scenario over here. Now for part D, as I mentioned before in class, I could put a question like this on the exam. Here's a question where you think, okay, it's obviously false, but reality is going to be true because 2 over 3 is 0. 3 over 4 is also 0, so 19 plus 0 equals 19 minus 0. Well, I think that would be true. And the same thing over here, this is actually, these two, B and C, are kind of fun because, you know, 60 is a really weird mod division. I mean, like, it's hard to do this part. But if you take any formal logic classes, this is, I believe, a tautology, and this is a contradiction. So that means that for this situation, notice how these two are the same, or not the same, but we have equal, not equal. That means this number, 234 mod 67, cannot equal 52 and at the same time not be 52. So one of these two has to be true. So this is going to be a true statement, obviously. For this one of these two has to be false. One of these two is going to be false. So if this is true, well, that's going to be false. If that's false, well, that's going to be true then. So this would be obviously false right here because this is a contradiction. So this is also like a little kind of like a question that makes you think like, oh, why would he have us do this division, you know, on paper like that, you know, on our head? No, well, you can sort of think of it logically and see that that's the answer there. Now, I'm not going to really have a syntax error type question on the exam, so we can move on from there. Let's go ahead and cover this example. This could be a fair game question on the exam. I mean, it wouldn't be as large as the example here, but this could be a fair game question. So trace out this code. So here's some code, and here's some input, and you know, give me the output for this program.